exit out of here. Oop, not exiting. Exit. All right. Stored in data.txt, which is a hex dump of a file that has been repeatedly compressed. For this level, it may be useful to create a directory under temp in which you can work. Then copy the data file using CP and rename it using move. Okay, so we'll go ahead and make our directory in temp, and we're going to call it rook. We're going to call it 12 though, because since we're logged in as Bandit 12, we're going to have permissions for Bandit 12 creating this file. Later on in Bandit, we may want to also use a temp directory. And if we just call it rook and we try and use rook again, well, guess what? Somebody else owns rook. Just because it's us logging in doesn't mean anything. It's really Bandit 12 logging in. So we'll call it rook 12. And then we'll cp data.txt to temp rook 12. And then we'll cd to temp rook 12. And there's our file, right? Data.txt. Cool. Now, we will, so this here says that it's a hex dump of a file that has been repeatedly compressed. So we probably want to xxd, or I'm sorry, let's start from the beginning. I'm jumping ahead. So a hex dump is an interesting word, and we don't know what to do with that, right? So let's read hex dump Linux, or let's say bash. So what a hex dump is a hex representation of binary for us to, understand it a little bit better, for the computer to actually be able to display it in useful characters for us. So there's a utility called hex dump. There's a utility called OD. There's a utility called XXD. A bunch of different utilities. We look through here, we see that XXD is in our list of things to solve, commands to solve this level, right? So let's take a look at that. Let's man XXD. So revert is an interesting word here, right? So if we start looking through here, reverse operation, convert a hex dump back into a binary. So that's probably our first step, right? We have a hex dump of a hex dump of a file that we need to extract. So xxd revert data.txt. Whoop. Let's okay, so we took this hex dump, data.txt, and then we reverted it using xxd minus r to its old binary. And this is its binary, and I effed that up. So instead, we did that again, but we redirected it called data.bin. If we run a file, data.bin, gzip was used to compress it. So we should be able to unzip data.bin. Can we do this? I wonder if we can do this. Oh, that's pretty cool. So we did the data, but instead of redirecting the output, this binary, into data.bin, we actually piped it to gunzip, gunzip, which gave us this different output. We redirected that to data2.bin. Now, if we do this again, just to be ridiculous, and we do this to data3.bin. bzip2 again. They are different. Oh. bzip2 again? Come on, man. So this is probably an instance where... Ugh, why do I keep doing that? It's probably an instance where... oops, probably shouldn't have done that. Oh well. This is probably an instance where scripting this would be a lot faster and more useful, right? File data5.bin. Why? Why all the bzips? I wonder if there's a... Ugh, keep doing this. I wonder... if there's a way to repetitively decompress bzcat, decompress files to standard out. Wait, I'm just being dumb. We're stupid. Well, I'm stupid. You guys are laughing at me right now. Ah, okay. It's VF. Oop. Oh, we don't need F because F specifies a file, right? And we're just piping to tar. So if we file data4.bin, cat data4.bin. What? Hold on. Oh. So, okay. So it already did the data5.bin. So if we file data5.bin, tar xvf data5.bin, data6.bin. Is it messing with me again? Am I messing this up? Data8. Hold on. So we did 6. Oh. Bull. What a pain in the ass. So I guess I got caught up in that without actually explaining what the hell was going on. So if we look, we reconstructed the file and we ran file on it and we found out that it was a gzip. So we ran the utility gunzip on the data, right? What we discovered is that we can actually just pipe it to the next one. So we, restored the file, piped it to gunzip, piped it to bunzip, piped it back to gunzip, and then fed it through tar. These are all just different types of compression formats, different compression utilities. And there's GZ for tar, GZ for gzip. There's BZ for bzip. There's tar for a tar file, which is really just kind of an archive file. There's no inherent compression in tar, I don't think. Yeah, so this was just an exercise in frustration as we use the file utility to find out what kind of a file it is and the correct compression algorithm to decompress the file and then repeat. So so let's get that password again. So if you are, what I would suggest is if you're following along or planning on doing these on your own later when you don't have my answers in front of you, but you want to kind of retrace your steps, do yourself a favor and open up a spreadsheet or a text file or something and keep track of these passwords. I'm not going to bring it over to the main screen, but I have an Excel spreadsheet or a Google Sheets that I have the passwords and then quick notes on kind of how I solved it. That way, when I go back, I can kind of go, oh yeah, that's what I was doing. But additionally, if you lose your clipboard or you lose your terminal or you walk away from it and come back and your computer's rebooted or something crazy, you can pick up where you left off instead of having to resolve every single one of these puzzles. I, of course, have never had to do that. I have a friend that did, because we all have friends that do that. But seriously, it'll save you a lot of time because it's doubtful that you'll do all these in one sitting. So Okay, so we're on to Bandit 13. Oop. An SSH proof key. Cool. Let's see what this wants us to do. I imagine that it's going to want us to SSH as the next, as Bandit 14 using this proof key, but we will find out. We will soon learn. Can only be read by Bandit 14. Don't need a password, but we need a private key, private SSH key that can be used to log into the next level. Okay, so we have this SSH private key, right? Let's take a look at it. So what these are used for, if you're not aware, is that there are multiple ways to SSH. The way that we've been doing it today, and the way a lot of people do it, is just username and password. But there is a stronger way to do it, as long as you can keep a key private. Now I'm blasting this all over the internet, but I don't think it really matters. But there's this concept called PKI, or public key infrastructure, where you use asymmetric keys to either send secure emails or authenticate, or whatever it is you want to do. What the public key means, what that's referring to, or what the asymmetric key is referring to, is that there's a public and a private key involved in the transaction, and I hold on to my private key. I don't let anyone else see it. I definitely don't stream it on the internet, and that's my secret. I have that, and then I can distribute the public key to whoever I want. And the public key has the ability to encrypt messages for me. It has the ability to basically just create things. Anybody can create things that only I can read. That's what the asymmetric means. It's two different keys, and they perform different functions. The way SSH works using public-private keys is that you generate a key pair, and then you put your public key on systems that you want to be able to authenticate to. Then, when SSH starts up, it starts up the SSH tunnel. You present your private key. The host machine verifies that it's your key and that you have it, and you're able to log in. It's, again, as long as you can, and there might be some rock stars in the audience like groaning at that explanation, but again, this is just a beginner's webcast. This is just kind of give you the idea of how things work. It's obviously much more complex than that. If you ever want to know how complex it is, do -VVV in your SSH command, and it will show you every little thing that happens on the back end when you spin up an SSH connection. I'll let you guys do that and kind of explore that and Google around and figure out what each of those steps are doing and how it works. Very educational, but that's much more of a tangent than I'm expecting to get off on right now. Also, I apologize. The trash truck is like right outside my window right now, so might be a little bit loud, but we'll push through. So I'm going to use this private key to authenticate to ourselves. I am going to use the I flag to use an identity file, and that identity file is going to be the SSH key.private in the local file directory, or the local directory. And then we're going to do bandit 14 at localhost. And so this is the other way that you can authenticate, using the username at the host. The reason why we're having to do it this way, and the reason why it says localhost is the name for the machine you're working on, etc., is because this private key goes everywhere. It's used by freaking everybody that ever plays these games. They don't have key authentication set up externally. They only have it set up for local authentication. So we have to SSH from within the machine to be able to access the key-based authentication. So localhost is a keyword. It's a magic word. It's a shortcut word that refers to self. You'll probably have seen the thing saying the bumper sticker or the doormat that says there's no place like 127.0.0.1. That is the magic IP address that every machine has that refers to itself. Localhost is the name for that IP address. So just like Google has a DNS server called 8.8.8.8, and it's got a name. Every machine has the local address of 127.0.0.1, and the name for that IP is localhost. So we're going to go ahead and authenticate. Yes. Ta-da! So all of that worked. We successfully used key-based authentication to SSH to a machine. Now that you guys have done that, I want you to consider, if you're using username and password in your environments, ask yourself why you're doing that, and ask yourself if moving to a key-based infrastructure, a key-based authentication method is viable for your environment. I can almost guarantee you it is. Don't just go changing shit saying, hey, this guy on the internet said to, but look into it and see how viable it is. It's a much better way to authenticate. It's much more secure. And it also prevents your users from having to remember like another crazy long password, right? And that's important. So the password that we need is here. So we'll go ahead and we'll use tab complete that we learned earlier. Bandit pass, Bandit 14. And here's the password for Bandit 14. So we're already logged in as Bandit 14, but really we want that password so that if we were to stop here, we can just come right back here when we need. So we'll exit Bandit 14, we'll exit Bandit 13, we'll SSH to Bandit 14, and here we are. Now we're on Bandit 14. So as you can tell, this is about halfway through Bandit. I'm going to use this point to use the restroom, grab myself some water. Generally just take a few minutes, go ahead and stand up and stretch. Sitting at your computer desk for long periods of time isn't going to be good. I'll be back in about 5 minutes, so you can go ahead and start your timers, and see you then. Oh, and check out the super cool new like break window. That's so cool. Thanks again to my wife, the ever so talented @Tanya Bjork on Twitter. Check out some of her stuff. It's great.